Okay, to follow up the giant ones review that I just created, I'm going to just talk about the super giant ones. The super giant ones, again, that's really not a math thing. That's a way we learn to remember how or why things work. So some of us were taught to divide fractions by, let's say, if we have 3/5 divided by, I don't know, 1/10, we are taught, okay, well that just means we're going to do 3/5 and we multiply by the reciprocal of the second fraction, 10 first, we get 30/5, that equals 6. Okay, some of us remember that, some of us confuse the rule, and because at this point all this is it's a rule. It's a rule that we're following. But mathematicians, we need to understand why. Why does this work? Okay? The supergiant ones was one of the ways we learned to prove the reasoning or the existence of this rule. Okay? And let's go ahead and investigate. Let's look at this same division expression, 3/5 divided by 1/10. Okay? But before we do that, let's go ahead and review some of the things we've talked about and some of the patterns we learned. What we learned before is that if we have a division problem, let's use whole numbers. 2 divided by 5, we know that equals 2/5 because we have two whole, I don't know, licorice bars or licorice. If we divide into two with 5 people, each person is going to get 2/5. This first person will get 2 pieces, second person will get 2 pieces, third person 2 pieces, fourth, fifth. So person 1 will get 2/5 of a licorice, okay? And the rule is going to continue no matter what you use. 5 divided by 7 equals 5/7. 6 divided by 5 equals 6/5. Of course, that simplifies to 1 1/5, but it does equal 6/5 as well. Even if you use variables, x divided by y equals x over y. Now, what about fractions? What about fractions? Is it going to work? Well, yes, it does work. Let's use the fractions we were talking about before, the 3/5 divided by 1/10. So 3/5 divided by 1/10, it's going to equal 3/5 over 1/10. 3/5 over 1/10. Now I'm going to scroll down a bit so we could have more space to work on that. So let's go. I'm going to rewrite down here. 3/5 divided by 1/10 is 3/5 over 1/10. Now the same goal, one of the goals we're going to have, I'm sorry, not the same, but one of the goals we're going to have is to get the numerator equal to 10. So to do that, we know that if we multiply it by the reciprocal or the multiplicative inverse, do not confuse it with identity, but the multiplicative inverse or the reciprocal, we'll get something that equals 1. So we know that 1/10 times 10 over 1, or just 10, equals 1. That 1/10, 10 over 1 is the reciprocal of 1/10. So if we consider that we can multiply the top by 10 first, that's the supergiant one. That's the supergiant one. Basically, we're multiplying the denominator in this case by its reciprocal to get 1. Now if we multiply the top by the reciprocal of the bottom, 3 times 10 is 30. 5 times 1 is 5. That simplifies to 3/5, which simplifies into 6. So we use the supergiant one, as we see here, we use the supergiant one to prove the existence of the rule we talked about earlier, to prove that 3/5 times 10 over 1 is just equal to 3/5. I'm sorry, 3/5 divided by 1/10 is the same thing as 3/5 times 10, because if we look down here, let me go and highlight it right here, this multiplication expression, 3/5 times 10 over 1, is seen right over here when we multiply the 3/5 times 10 first to get the numerator. The denominator doesn't really matter at this point because it's going to equal 1. Okay, so this is the supergiant one.